share with you our success story from one of our data science projects that we have developed by Exact. And how many of you have ever heard about Exact here? Wow, nice. Oh, how many of you have heard about Exact? Yeah? Nice, really, really nice. Well, I'm just gonna give you guys a bit introduction about our agenda for today. So I'm gonna give a bit of an overview of what is Exact and what are we trying to solve here, and what did we do, how did we solve it, and what is the value added for the company. First of all, Exact is a, well, I mean, you guys already know, but it's the first company, first financial and ERP software in Benelux. And we have some financial solutions, and I'm going to be focusing more in Exact Online. That's where we are currently developing our data science and machine learning projects for. We have a quite big structure, so we are more or less 1,400 employees, and we serve more or less 6,500 accountants. And for the last 2 years, we have started this big journey into the data science world, and with that, we're delivering. I'll show you more what we're delivering for our customers. Yeah, what actually are we solving? What is the problem that we're trying to solve here? A little disclaimer: all the data that we use is anonymized, and it doesn't live Exact, and it's all fine, all good. How many of you know more or less something about bookkeeping? Wow, good, great. Well, I'm going to give an overview just to keep everybody on the same page. Here goes. We're trying to solve a problem that every company has in terms of booking their transactions. So every bank transaction, every payment, every transaction in general that happens within the company, it needs to be booked for taxes purposes or for their own investigation on what's happening, how the company is doing. So we are trying to make it easier for our customers that they don't have to do it manually. And within Exact, we already have a solution that customers can import their bank statements, and then it's already one step further. You don't have to do the importing bank statements manually, but now we are also showing the general ledgers that those bookings should belong to. And what is a general ledger? Basically, it's like a drawer where you're going to put some specific invoices. So, for example, if you have paid on overtime something, then it goes to the drawer foods. And if you paid the Belastingdienst, then it goes to the tax drawer. With that being said, that's more or less the automation workflow that we developed, that there is already in the company, and what we added. So there is a payment, and this payment goes through the bank, let's say, and then we get that bank statement from the bank, and then we insert it in the software, Exact Online, and then we automatically will give you which of those drawers we should put it in. So we're trying to make it an automatic bookkeeping, saving time and saving effort from this manual work from our accountants and entrepreneurs, so they can be more insightful in what they're doing and not losing so much time on the manual job. So this is more or less how it looks. So yeah, this is the screen. Like when you push the bank statements, those are the suggestions that it comes from. I don't know if you can see very well, but yeah, in the left corner you see the GL accounts that we are suggesting. So we do it at the top 3 GL accounts. And how did we do it? I'm going to invite my colleague Narendra to specify a little bit further.
Thank you, Mariane. I hope this works. Hello. Yes. Hear me? Yeah. Thanks, Mariane, for the nice introduction. Yeah. Oh, I need to keep it like this. I don't have this. So as already Mariane has explained, we want to actually introduce the no-hands accounting. So basically, we want to help accountants so that they don't need to do the data entry and the data crunching. We want to do everything, and we want to make automatic processing so that they can focus more on advising enterprises. Because right now, they are more busy in trying to get the data in time and do the data crunching. So we want to help them so that they can do actually advisory, more focus on the advisory, so that they can help enterprises to grow further. So as a part of it, we have built some AI products. I'm sorry if it is echoing. As a part of the AI products, Data Lake is the first product we have, and next to that, we have some RGS product, which is actually unifying bookkeeping system. So what is the purpose of this product is actually every company or every enterprise has its own chartered accountings, because they book, for example, if you have a transaction from Albertine, someone books into a food, someone books into a general. So we want to actually make it more uniform. So actually we use RGS. RGS is actually a service, actually the government service, where they want to actually unify anything related to the food or anything related to the tax, they have to map to the certain code. So actually we make sure that every enterprise follows these standards. Even though they don't follow the standards, inline we use the RGS and make sure that they follow the standards, so that it's useful for us when we have a new transaction, we can map it to this unified data entries. Next to that, we have a lot more products, like, for example, the KPI benchmarking. Basically, this is about how enterprises are doing in market. For example, the sector-wise, how the professional services are doing, how the hospitality services are doing, so the enterprises can themselves compare how they're doing across the industry or across the Benelux. And we have some forecasting services, but right now we're going to focus more on bank transaction mapping. As we already, Mariane has explained, we have a new transaction, and we would like to map them to a GIL, and we would like to do it automatically. We would like to give them some recommendations so the customers can choose. So as a part of it, we first need to build a data platform, because we need to collect all the data. So we need to actually use the historical transaction data to learn how actually it is being happening. So based on that, we build a model, and we recommend them how to map it. So as a part of it, we collect the data from multiple sources. So we get the data from the cloud systems. We also get the data from some local systems. And we also get some reference data, for example, the RGS, something which we can say in files. And we also try to collect some social information, like how actually customers feeling about our products for the social analysis. And the data is being dumped into a landing zone, we call it. So it's actually a raw data, as is. It is being dumped into a landing zone. And from the landing zone, actually, we harmonize the data. So harmonization means actually we standardize, we partition the data, we clean it, we transform the data. And once we have this data, we actually send it to we use this data, actually the harmonized data, for actually to do the feature engineering and modeling purposes. So our data scientists will access the analytics arena and do the data analysis and do the modeling and the feature engineering. And the purpose of the data lake here is not just to do our data science projects, because we collect so much data, we can also help a lot of other business units actually within the company. So we actually also try to give an access to the data consumers within Exact. So we also have data consumers who actually access the data from our raw data source, as well as the standardized or clean data. On top of it, we have a data management. It's very important that we comply to the GDPR things. So for example, opt-in, opt-out. For example, if the customers don't want us to use the data for their modeling purposes, we would like to ignore the data for not to target the users. So we have a data management platform on top of it, and we have a data governance. So we also would like to see who is accessing data and what kind of analysis they're trying to do, and if they are actually also compliant to all the compliance. And then we also have a data operations. We also would like to understand on a daily basis how the data is being processed actually across the platform, how many transactions being coming in on a daily basis, and what is the performance of our ETL jobs. So actually we have built a dashboards with Power BI, and then we call it as a data operations. So since the talk about here is actually how we utilize AWS services, so actually the most persisting issue which we had when we were building this data lake was actually like managing the memory on the Spark in EMR. So whenever we run the jobs, we always run out of the issues, most probably the out-of-memory errors. I think everyone has those issues, I assume. So the common issue which we had is like, okay, out-of-memory error. And we had two solutions provided by either Spark or from AWS. One was we can use the maximize resource allocation from AWS so that it automatically sets the size of our Spark executors and driver. So you no need to worry about it. AWS does this for you automatically, but there is a shortcoming for it because it still does not utilize the cluster very effectively. So we're going to go more detail into it, how. And the second option we had is from the Spark or from the Yarn, we can use the dynamic allocation enabled. So actually it scales the executors based on the workload. The Spark itself can scale it up, but you need to come up with some sub-properties like initial executors, minimum executors, or max executors. So basically you want to allocate something. So you would like to share now the resources with multiple applications. So you need to come up with at least a minimum requirements so that your job runs. But it is possible that, okay, if there are two jobs running in parallel, you might lose again some resources. So actually we were using the maximize resource allocation from AWS, but we had some issues. So I'm going to look into one of the issues which we faced and how did we solve it. So let's consider the clusters, this one. So we have worker nodes and the cores for node and the memory for the node and the cast. So we have a scenario, old scenario and the new scenario. So we had a worker nodes of 10 and each node has a cores, 8 cores for the node and as a memory of 32 GB. And it was costing us around, let's imagine that 100 euros. And we realized that with the same amount of resources, we can get it from the 3 clusters, 3 nodes available in AWS, and we can do this in a lot cheaper way. So for example, if you go with the 3 clusters, worker nodes, and each node has a cores 32, and each node has a memory of 236, actually it is same as what you see on the old scenario, but actually it's a lot cheaper when you compare to the old scenario. And when we try to use the maximize resource allocation, so this is how the maximize resource allocation works. Actually, when we try to set this maximize resource allocation to true, it uses one of the node, worker node, for the driver. Actually, so all the resources available in one of the node is allocated to the driver. Driver is actually like high-level orchestration for all the tasks, which is being executed by executors. So this is good with the old scenario, because you see that one of the node has been allocated to the driver, and you just allocated 8 cores and 32 GB to driver, and that's fine. But if you go to the new scenario, then you end up allocating actually more resources now because you only have 3 nodes, and one of the node is totally allocated to the driver, then actually 33% of the resources have been sent to driver, but driver doesn't do any work. It just tries to collect all the information from your executors. So for this, we cannot use the maximize resource allocation, so we need to do the configuration manually. So we need to split the bigger nodes into smaller nodes efficiently so that we try to have the same scenario as how we had in the old scenario so that we only use 10% of resources for the driver and the rest is being used for our executor purposes, so to do our job. So we did some lot of research and also went through a lot of papers and even AWS consultants. And we came up with the approach. And the approach is like this. So we need to decide, actually, how many nodes or how many executors we need to create in each node in such a way that we minimize the unused memory and cores. And we also need to make sure that there are some regular tasks, the OS-related tasks, which needs to be carried out in each and every executor or the instance. And we support those kind of activities. So we lock some resources. So the number of nodes we had here was 3, and the memory was 236, and the cores for node was 32. In that, we lock, because we need an overhead, the Java heap space purposes, we lock 1.1% for that purpose, and the reserved cores for the OS, 1 core in each instance, and reserved memory for the OS, 1 gigabytes in each instance. And we also try to set some how many tasks we can run in parallel in concurrence in each core. So we set some variables, we fix those constraints. So once we have fixed those constraints, then we have a memory available is actually will be reduced by 1, and the cores will be reduced by 1 again. And we split them now. For example, how many executors we would like to have. For example, let's imagine that you would like to have it 6. Then we will see, okay, all the yarn configurations, how does they look? Then we will have instances 17, and the overhead will be 4 GB around, and the executor memory will be 35, and the driver course will be 5, and the driver executor course will be 5. And here the catch is, the AWS consultants and everyone suggests us, executor course upper bound should be 5. So that's the max limit. If you have more than 5, the performance will be not that effective. So it would be good to have 5 or below 5. So that is an upper bound which we will set actually for a course. And also we have an upper bound for the memory, because 64 GB is already a lot more memory, because that's the file size which we set in our Hadoop or AWS instances. And we also see the scenario 2. Okay, if you divide each node into 4 executors, then how does our resources look? Once we have this, we will check where do we lose most of the resources, or where do we utilize most of the resources. In the first scenario, actually, we only lose 1 GB of memory, which is unused, and we only miss 1 core. And in the second scenario, actually, we don't utilize 3 GB of memory, and 3 cores are unused, actually. So we will go for the best option. So we will try to pick the option which is actually utilizing the most of the resources. And we also need to catch here, like, okay, we also need to check with the upper bounds. So the executor memory and the driver memory and the cores, executor cores and driver cores are not exceeding our upper bounds. Because it is possible that if you set it to 3, you might be still have most utilized executors, but then actually we exceeded the upper bounds. So we also need to make sure and have a check on that. I will hand it over to Bijan to explain how actually things works in detail.
Sure, thank you. Hi everyone, I'm Bijan, data scientist at Exact. So let me take one step back and again look at the overall process that Mariane introduced in the beginning. On the one hand, we have data lake of what Narendra said. So there's a lot of work in our team that goes onto the data lake, but that's just the beginning of the whole story. On the other extreme, we have the customers. In this scenario, they have a bank transaction that is coming through the software, and they want to know what is the category or GL account of that software, that transaction. From the data lake, we can run an ETL, having all the analytical records in the data lake, easily getting the training and validation data sets. And part of that, the training set, goes into the classification model, and we train a model there. I will talk about the model a little bit more in the next slide. The other part of the training set, which is the validation set, goes for the validation. So we want to make sure our model doesn't get overfit, we stop the training in the right time, and having an estimation of its accuracy. Then this classification model is exposed to an endpoint using the Sagemaker basically component of AWS that I will also talk about a bit in a few slides. And then the bank transactions go through some intermediate departments, let's say, or components. At Exact, they get anonymized, some basic checks happens on them, and then the text and some other features goes to the endpoint. The results are sent back in form of prediction results into those intermediate components, and then the top 3 categories are sent to the customer that hopefully is happy. There is also one other very important step for us, which is the long-term evaluation. So we deploy the model, users start using those models, basically customers start using the products. In 3 months from that time, we look back at the results and we try to evaluate what's the percentage. And it's always interesting to see in validation, we get some accuracy. We try to make it as close as possible to the evaluation accuracy, but still what we see in real world is always a bit different. Let me also have an overview on the model itself. It's, well, not very technical, a very standard LSTM basically example. So we have input data, which is like this Albertine and number from Delft, let's say. And that is the text that is fed into the model. The next layer is vectorization. So we want to assign numbers to these basically words, which is the right index for them. And also if there's other data, that should also be vectorized. And that vectorization by itself, given that we have like 100 million transactions for training, can be a very heavy task. So sometimes vectorization by itself can be more heavy even than the training in some sense, depending on the machine we use. The next level is word embedding. So the idea is to assign vectors to each word such that the words that are similar get vectors that are quite close to each other, right? We use word2vec. We sometimes train our own, basically, word embedding based on the data that exists at Exact. Sometimes we use the standard word2vec data sets, word embeddings. There are pros and cons for each. If we train it ourselves, it's a lot more customized for our data, though it's not very good at the new data that is trendy and comes into Exact. Like Wikipedia, for example, type of data sets are a bit more robust to what comes new. Besides, if we train it ourselves, there will be a new pipeline we should try to keep on updating and keep on retraining. So sometimes we avoid that, but depending on the product, we have both options. Then comes the standard deep neural network, in this case LSTM. So we have many layers of LSTM, different words in form of a sequence go to each layer. The results of that layer plus there is the new word go to the next layer, so on and so forth. And at the end, we have a softmax layer and the predicted categories. Of course, there are so many hyperparameters, the number of layers, the dropouts, basically so many other parameters that we experiment a lot on offline with small amount of data and different frameworks until we get to the right setting, right? But let me quickly talk about SageMaker. Maybe just a quick question. How many of you know SageMaker or have worked with SageMaker? Okay, so let's say half-half. So SageMaker is an AWS fully managed service for machine learning. It's kind of plug and play in many aspects. The first layer is the ground truth layer, so it allows you to collect your data, label it in a professional way. Second layer provides notebooks that you can use the SDK of AWS SageMaker to, in a very easy way, take algorithms from SageMaker, collect the data, do trainings, and so on and so forth. The third layer is the training layer. There are a lot of off-the-shelf available models and algorithms to train, but also you can provide your own model basically to train on that, but use the SageMaker containers basically. And the last layer is inference, so how to productize a model in form of endpoints. For us at Exact, the last two layers are very, very useful and handy. So we usually develop our models basically in EC2 instances. We make a container, we provide it to the SageMaker, and then from there on, we use the SageMaker steps. And I thought probably it's interesting to mention a little bit about how we handle the cost and performance optimization. For example, in SageMaker at the Ireland sector that we use, there are two types of machine GPU-based instances available, the P2 generation and P3 generation. The P3 generation is using NVIDIA Tesla V100 GPUs, so it's a higher generation, more advanced generation of GPUs. And when we train a model, the P3 shows a lot better basically performance. So it's between 3 to 5 times faster in training models compared to P2. So if a training takes something like 3 days using P2, with P3 I can finish it in 1 day, and depends on how long it takes. Though a problem we face is that if I use P3.8, it costs $18 an hour. Then if a training takes 10 hours and I want to do 4 trainings in a month, it's easily $720 a month, only for the training part of SageMaker. Of course, there is the endpoint that should be always up and running. There is a lot of offline experiments that should happen in advance. There are the EMRs involved, so the cost can easily explode. And we continuously try to see how we can use, for example, in this scenario, P3 2x large, which has less memory available compared to P3.8, but still use the P3 because having a training fast is also very important. A few tips, some things that we tried and we found very useful. Using data generators to stream data into models, for example, is very handy. Because if I have, let's say, 80 gigabytes of data that should be used for training, I don't want to load this all into the memory, for which I need a P3.8 maybe, and do the training. So I can use a generator to stream data into the model and do the training, though it can also slow down the training. So there's a trade-off there. Vectorizing data with non-GPU instances. So if I want to vectorizing, I don't need a GPU. Pipeline becomes a bit more complicated, but that's important. And hyperparameter tuning also can help a lot with the speed. And a few challenges before I hand over to Mariane. So the problem I explained was a very standard problem. In real-world scenarios, we have a lot of challenges. Very short and abstract text. So you have a bank transaction that probably is just a number, account number, that's it. So that makes the kind of detection much more difficult. So we have to look at the date and the amount and a lot more scenarios. Trends over time. So a lot of mappings over time in summertime, close to Christmas time, just changes. So that's something we have to handle, keep on training and be prepared for. Regulations of the government get updated. So like very often we get new versions of RGS codes, for example, and a lot of changes that we have to adapt to. And different businesses need different mapping. So Albertine for a company can be private cost, for the other company can be just the stock, and things like that. So I hand over to Mariane, and I come back again at the end to wrap up. Oh, sure.
I think I broke it. Well, I'm going to talk a little bit about the orchestration and how did we actually manage to get all of this working and productize everything in a very compliant way to how we should give it back to the company. Well, so we use step function for the win. It was really good. I don't know other service that could have helped us so nicely with this idea of this project as the step functions did. So for the ones who don't know what step functions are, a step function is a service from AWS, which is an orchestration tool, and it helps, it links a set of resources. You can link with a set of resources and make your own workflow with whatever you want. So you can link with Lambdas, you can link with Dynamo. There are sets of stuff. And here in the left, on the right, I suck at that. You can see so here, each chunk of code here is a step that you define for the workflow. So the first one is, for example, notify Slack. So we know when the whole thing is started. And for that, we trigger a Lambda function, which notifies Slack. And on the left, you can see how it actually looks on a workflow. And what is really cool about the step functions as well is like you can set data for input, and that will be processed by the resource, and the output can be used on the next step as input as well. So here, as you can see, just as an example, for example, we're going to run the EMR data collection. We're going to get all our data, and then we're going to start, wait until the data collection is done, and then we're going to start the training. And this workflow, it's complete from gathering everything, the data, vectorizing, creating the training job, and then all the way to deploying the endpoint. We also have something really cool here that was really useful for us, which is bookmarking our last endpoint configuration in order to perform some rollbacks in case something didn't go well. We store the data in a DynamoDB, and then later on we have a Lambda that's also linked to it, and it can update well, I'm going to talk a little bit better about it soon. As I mentioned before, all these cool things that we said previously cannot go productized, you cannot go all the way to our customers if you don't comply to some standards from the company, because we're adding products to an existing product, and you have to follow the highlights of it. We follow some guidelines called non-functional requirements, and for that we need to follow quality assurance. So we have a lot of experts looking into what we've done and how, and our way of working, if we tested, if we didn't, and we have to prove that we tested everything. So step function also helped us in that flow. We have to comply with security if our IAM roles are very much focused on a specific job or a specific resource that it has to work with, or if it's just a star there that everybody can call, we should not do that. Also, we use a tool called Black Duck to scan our libraries that we're using. So that's good for security as well as for legal. Legal also takes a look on the licenses that we're using, and we have to comply and make sure that we are doing things nicely. So this is more or less how Black Duck looks. It shows like some security risks. So some are not necessarily bad because it might be that you're not using that piece of code that it has some issue, or you can evaluate, and some risks can be accepted risks. It shows also some license risk, depends on the license, because open source might not necessarily mean that you can just use it and sell it. So things like that to really pay attention to and make sure that we are following all the protocols. Sorry? No, this is for actually the libraries that we use. So for within Sagemaker from the container, we look into things and we make sure that we are using things in a nice way. About infrastructure and operations, we also have a team supporting us to make sure that if something goes not well with our model or with our endpoint, if something is down, that they will help us to take care of it and they will help us to put it back in place. And for that, we have performed the rollback mechanism. So for the rollback, in the middle of the step function, we have one step that stores the previous configuration for the endpoints, for the Sagemaker endpoint. And then when we run the rollback Lambda, it gets the data from the DynamoDB and updates the endpoint in Sagemaker. And that Sagemaker takes care of everything with the time to change the endpoints, and it's everything managed. We also have some monitoring mechanisms. I here show you, we use Splunk for some of the monitors. Some of the monitors use Power BI, but it's everything coming from CloudWatch. And here we can see if something has had like some peaks or didn't go very well. We can easily see how did it go. And of course, again, to comply, to comply with infra in a deep level. So make sure that we have documented, and also that we don't create anything manually. We use Terraform, which looks this nice. This is an example of creating a step function. So setting up the state machine with all the dependencies and variables that we need to make it run. And that was it. I'm going to ask Bijan again to explain a bit better.
How much time do we have? Yes? Okay. Thank you. So just to basically wrap up the whole pipeline once more, is that we start from data lake, we go to the training of a model, deploying the model, serving it, and also evaluation in long term. And we use a lot of different AWS services. We already mentioned EMRs, Sagemaker, CloudWatch rules are a lot used. EMR again for evaluation, of course, a step function, a lot more products, AWS products there. Something that has become more and more important for us, the more the ecosystem of AI products basically grows at Exact, is monitoring. So for example, we use Splunk a lot to monitor the infrastructure and the software engineering, data engineering parts of the products. And for example, the Power BIs that are the Power BI dashboards that are more basically accessible for data analysts and data scientists, and it's a little bit easier to work with and make it available at the company. And again, we use, for example, AWS Athena a lot to connect Power BI to a lot of results that we have that are crawled with the Glue service, for example. And we use the Kinesis to stream data toward the Splunk. And so I can't emphasize enough how important monitoring is for us. Just the more products, the more continuous monitoring, alerts, and making sure everything's in order 24/7, basically. Then let me sum up with the values added. At Exact, based on the last study that was done, 1.3 million booking suggestions are used in a month by customers of Exact. That is a result of the product we introduced, plus a few more AI products there. The time needed to book a transaction has decreased from 15.20 seconds into less than half of this number, which is something we're very proud of. Most of the features are provided such that it's a one-click booking. It takes less than a second to use the examples that we provide. And at the end, 2,975 hours potential time saving per month, which we are very, very happy about. We prepared some takeaways, basically, for you. We hope if they're useful, and we can also discuss it, of course, so prepare your questions, please, for us. The first takeaway is understanding the problem and extracting characteristics to define the problem is very important. So toward developing such products, it happens a lot that we're stuck somewhere, like our EMRs run out of memory, for example. And well, there are different ways to handle it. One is to try an alternative method, and for now, to get over it, or just stay there, try to define it and solve it. And of course, it turned out to us that the more we try to understand the problems and really define them in a proper way, in long term, that pays off. Two, sophisticated data lake with scalability, flexibility, and convenience is super important. So developing AI products, having a good data lake is not a big challenge. Yes? I think so, but Naren probably can also say that. That's Naren's takeaway.
So actually, well, good way to escape. So actually, whenever we have a problem, the marketing team or the operational team, when they're coming up with us and they ask us to solve something, so it's important to understand the problem first, than just trying to jump on and try to solve it, because sometimes they mean something and we understand something. So it's so we need to make a trade-off, as you said, but it's important to understand, because once we develop something and then they say that this is not something which I expected, so that's not nice, so we don't want to have that scenario. What we meant was, okay, understanding the problem is an important thing here, and we also need to see how can we formulate the problem, because they can explain you a problem, but then we need to see what kind of data we have. Can we be able to formulate that problem using the data we have underlying in our data lake, things like that.
Extracting characteristics, I want to be sure you mean...
The features, the features which are required, for example, to understand certain problem. Yeah.
So you put this as a general list?
Yeah.
Universal?
Yeah, universal. Yeah, and some things which, and also based on what we learned with our existing projects and the challenges which we faced at Exact.
Yeah. Okay. So sure. So the data lake is helping us a lot. The more cleaner the data and the more better the layers of the data lake, the easier it is to develop products on top of that and do analysis. Number 3, diving deep into configurations of, for example, Spark, TensorFlow, things like that also pays off a lot in long term. What Naren explained in terms of the EMR configurations, it's not very easy to dive into that in the beginning, though in long term, when you have a good setting, that really pays off. Acting agile in deployment of models, it's like you're developing a model and it's very tempting to keep on improving it for months and months and months until you can feel confident enough to release it. That's one way, but also we can be agile. So we can have a baseline in 1 month, calling it version 0.1, and then after a while we have 0.2, 0.3, then we have 1.0, and so on and so forth. So at Exact, we're trying hard to be agile, deploying our models, labeling them with the right version numbers, so internally it's easy to communicate it to all the stakeholders, what's the status, and keep on improving it, rather than spending months on developing something that at the end you don't know what the status will be. Number 5, being aware of new technologies. For example, I mentioned the P3 type of instances for Sagemaker compared to P2. It can be easily that there is something there on AWS or some libraries that it's there, it can solve your problem, but we're not just aware of it. So it's very important to stay up to date. That's why we're all here, of course. Number 6, designing rollback mechanisms. That also helps us a lot. Things fail anyway, doesn't matter how good we design them, it fails. So it's very important to have a rollback mechanism such that we can avoid the stress and tension, and then we have the time to improve. Don't add automation to make you ignorant to monitoring the process. To us, it happens that we automate processes so well sometimes that it keeps on running on the background every day or every week without me noticing anything anymore. But the danger is that over time, there might be issues in those processes and it accumulates, and at some point we have problems. So we try to automate things, at the same time keep on dashboards everywhere and make sure we keep on monitoring the situation, which is very important. And the final one, it's very important to share, communicate, and collaborate within the team on a daily basis. That's why we are here today with 5 of us, right? So we have a really, we are so proud of our team, continuously collaborating, communicating, and this sharing part, because sometimes the scale of problems are a lot bigger than something that one of us can handle it. So we continuously on a daily basis try to share everything we know with each other, teach each other, and solve the problems. Any takeaways I have to add, or Mariane? Okay, then the last slide, we're so proud of the amazing team. We have data scientists, software engineers, data analysts, and data engineers. Yeah, there's also a quote up there that we make sure our customers don't think that our AI products are going to steal the jobs, basically. It's just more to make new opportunities and adding some artificial colleagues, of course. Thank you.